Today we are going to talk about limits of rational functions. Morning, Angel. So today is this pen is, I need a pen. Today is the 15th. Gentlemen, we're going to be talking about limits of rational functions. At each of your desks, you should have today's sheet. Good morning, Ivan. You should have this sheet, okay? We need some definitions before we start today. Let me change those who came in. Ivan. Okay. Rational function. I know that we've given this definition already. Let me know if I'm going too fast, okay? A rational function is a function created using a fraction where the numerator and denominator are, excuse me, functions. Thanks. That is a rational function. The key word is, I spelled rational wrong, my bad. The key word is rational. Rational should always trigger you to think of a fraction. A rational anything, a rational number, a rational function, a rational, I don't know, that's all we got. It's always a fraction. That is the trigger. You should know when you see rational, it is a fraction. When you're done writing that down, take out the example sheet. Morning, Anthony. Do you have a, you have to this way. Okay. Thank you. What's up?
I think you took ours.
I did?
Yeah, I think those policy papers.
Oh, my bad. Here you go. Make sure you all have a calculator. Extra. When you're done writing this down and you've taken out that sheet, I want you to complete that first two problems on that sheet. I want you to complete the first two problems on that sheet. That's these two, right? Yes? You can work in your group. I'm going to give you about 2 or 3 minutes to get that done. Make sure you have a calculator. If you don't, you can go grab one now. And of course, my timer is dead. Ladies and gentlemen, we should be working on this, not gossiping. Does anybody remember how to do this? We did this a couple weeks ago. What do I do? Replace the x with 2. Very good. So any x's you see in the first one, you replace with 2. What do you replace the x's with in the second one? With 4. Okay? How do you put a fraction in your calculator?
Alpha y equals.
Alpha y equal. Morning. How about 40 seconds?
Yo, I can't find the first.
What'd you get?
I can't find
You can't find what?
it.
Does that one might need to be updated. That's why it doesn't. Alpha. Okay. All right. I know some of us are not done, but that's okay. For this first one, you should have gotten something over 0. Your calculator, if you did it correctly, should have been error, right?
Yes.
What did we say last time if there is an error? D and E, okay? If you did this one, you would have also gotten error, which is D and E, okay? You're like, but Miss Santana, what does this have to do with today's lesson? You'll see. All right, let's look at the next example. We're gonna do this one together because this goes way back to the beginning of the semester. Bear with me. This all will tie in together. We're looking at the limit as x approaches 2 from the left. So we go from here to here. What is that limit? 5. This is on your paper, just so you know. This is like the second one on your paper. What is the limit as x approaches 2 from the right? 5. If these two match, what does that mean? That's also 5. Questions on that one? You sure? Can I go to the next thing? Okay, so now we're going to the next problem. Before I substitute in anything, what do you think I can do to these x minus 2's? This goes way back to algebra. Okay, let me do it in a different number. If I had a 3 on top and a 3 in the denominator, what can I do to them? Simplify, right? What would it simplify to? 1, right? So I'm basically dividing them out to be 1. Are these two the same? X minus 2, x minus 2. You're used to saying, I will cancel them out. Right? Remember this? Way back? Algebra? Maybe? Hey, we're combining algebra with calculus. I told you guys, we combine everything here. So when I cancel them out, that means they go away, right? It becomes 1, but I don't need to put 1. So now we have the limit as x approaches 2 of x plus 3. Now we have a simpler one, right? Because if I substituted in 2 here, I would get a 0. What should I do with this 2 now? Replace it with the x. So it's going to be 2 plus 3, which is equal to 5. So the limit is 5. Questions? What if I told you that all 3 of these problems, this one right here, this one right here, and this one right here, were the same function? You're like, nuh-uh, Miss Santana. Yeah, they're all the same function. This one right here is the expanded version, meaning like I multiply it out of this one, which is the graph of this one. So what was the limit of this? 5. What is the limit of this? 5. Today we're going to learn that rational functions don't always have a does not exist limit. Okay? Let's go back to our notes. I'm like, wait, Miss Santana, you lost me. Don't worry. I will bring you back, hopefully. Okay. So you're probably asking yourself, but why? Why is it that all three of those things were the same, but when I did that first one, it was does not exist? That is because we have something called discontinuities. If you remember a while ago, I talked about discontinuities. These are things that, let's look at the graph. This is a hole, right? It's not continuous, so it is a discontinuity because this part right here does not exist. Just at that part. But remember, we're not asking ourselves for limits, what is that value? We're asking what happens to the function when it gets close to it. So a discontinuity Discontinuity are points or values on a graph or of a function where the graph or function has no value. Am I off screen? Or does not exist. Oops. Am I going too fast? Anybody? Bueller? Yeah? Okay, I'll slow down. Bless you. Ready? Okay. So in calculus, we remove these points or values to calculate the limit. We do this by factoring. Now we know why I had you all factoring last week. To cancel, like I did in that example, out the common factor. Am I off screen? And then we can use the limit rules. So now we're going to go over limit level 1 and level 2. Okay? Everybody know what this? Yes, no, maybe so? No? Okay. Good? Ivan? Sure? Christian? Diana? I can't see if anybody's still there. Okay. Oh, Kevin, you were done? Okay, sorry. Good? Okay. All right, so for level 1, you're going to use a table. So I'm going to give you the rules on what you need to do for level 1 here, and then we're going to go practice level 1, and then we're going to do level 2 rules, and then practice level 2. So for level 1, you're going to have a table, and you need to find the limit as x approaches a from the left of f of x. So yes, for those of you who don't remember how to do this, we're going to need to remember how to do this. This is all combining together. Everything we're doing is combining together. For those of you who don't remember, this is the limit from the left. Then we're going to need to find the limit from the right. Morning. Do you have your tardy slip?
Not supposed to anyway because they put 118. In school, yeah.
Alright, I'll ask them. There should be a example sheet and then grab some paper. You know where the paper is, right? No, sir.
I said it wasn't costly, but no.
No talking. Alright, and then the last thing is you're going to need to evaluate to find the regular limit. Remember, there is one thing that has to be true in order for this limit to exist. What is the one thing between these two that needs to be true? Very good. They both have to be the same thing. They both have to be equal in order for this limit to be true. Otherwise, it's what? D and E. When you're done writing that down, take out your examples. Or the example sheet. This one. Yeah, it's up to you where you want it right here. Okay. Ready? Okay, let's look at this example. This example says find the limit using the table. So here is your function right here. All right, if we took 2 and we substituted into here, we would get something over 0. And I know that because 2 minus 2 is 0. we have a table here of values for this function. So we're going to need to find the limit from the left, from the right, and then determine if the limit exists. Think of this as a number line, okay? I'm going to turn it on the side here. This is a number line. Here is 2. If we go to the left, this is from the left. Am I off screen? So this is 2 from the left, because we're going to the left on the number line. And then this would be 2 from the right, okay? So we want to look, I'll wait until everybody's done like copying that down. We want to look at what happens to the values as it gets closer to 2. So as I get closer to 2, what is the value getting closer to? So we have the limit as x approaches 2 from the left of f of x. What is it rounding to? What's it getting closer and closer to? What is negative 2.01 round to? Negative 2. Questions on that? Okay, so we're going down for this one, and then we're going to go up for this one. So now we need the limit as x approaches 2 from the right of f of x. What is this number getting closer and closer to? What kind of 2? Negative 2. Do these two things match? So that means the limit as x approaches 2 of f of x is negative 2. Questions? Are we sure? We're sure. All right, when you're done writing that down, I need you to take out this sheet, flip over to the back, and I want you to work on numbers 1 and 2 with a partner or in your group, okay? Work on them. Remember, you need to show the left limit, the right limit, and the regular limit. Left limit, right limit, regular limit. Questions? All right, I'm gonna come back in 4 minutes. Good morning. Yeah, go. Yeah. Jocelyn. On the back. Remember, you need the left, the right, wrong side. You're on the wrong side. No. Sorry. This, but it's not. 8. What is it? Okay, that's it. This is correct.
I don't know about the rest.
Okay, give me 1 second. Let me give Faith the notes. Okay. Give me 1 second. Gentlemen, we're not working. Yes, you do. It's none of
Can I see your graph? I did do it.
No. Because remember, even though it says D, right, you have to look at the graph. I mean, hey, Justin, go back to your seat, please. All right, let's look at this. It looks like some of you are confused. So let's try one of them together. All right, what is the value that we're looking for? 3. How do I know that? Well, yeah, the error, but also what does the function tell me? It tells me to go to 3, right? So we need the limit as x approaches 3 from what first? What do we need the limit as x approaches 3 from which side first? From the left. Okay? So, okay, so we're looking this way. Where is this going to? What value is it approaching? 8. Remember, yes, it's approaching 3, but when we're looking for the answer, we're actually looking for the y value. So this is getting closer to 8. What about from the right? So now we're looking this way. Also 8. So what's that mean about the regular limit? It's also 8. Questions? Are we sure? Because a lot of us didn't even start this problem. And we have an exit ticket today. Yeah, it's only 2 questions though. It's only 2 questions. It's only 2 questions. Yeah. It's only 2 questions. You get to make up the exit ticket tomorrow. Don't worry. Only 2 questions. All right. What about this one? Where's it going to? -2. Oops. Why am I looking up there and trying to do this? So we need the limit as x approaches to -2 from what? No. I mean, which way? To the left. What's that value? No, don't round to 2 decimal places. Gentlemen. 0.08. See, we're rounded to 2 decimal places. Now we need the limit as x approaches 2 from what? To the right. What's that give us? 0.08. Don't forget the negative. Are they the same? Oops. Maybe if we're not understanding it, we shouldn't be talking and asking questions instead. Questions?
So you can only bring it up.
I'm listening.
2 decimals.
2 decimals, yeah. Okay, let's go back to our notes. I'm sorry, are there any questions on this? Are we sure? Are we sure? Because a lot of you didn't even start. Do we know how to start it off?
Yeah.
How do we start it off, Brian? Okay, we look for the middle. We look for the value. And then what? What limit are we going to look for next? That's okay. What limit did we look for next? From which way though? From the left and then? And then? The regular. Okay? If they're equal, what is it? The same thing. If they're not equal, what is it? The board's up here, gentlemen. The board's up here. The D&E, yes, sorry. All right, let's look at level 2 now. Level 2 now, we're going to be using factoring. But the good news is, the factor's already done for you, so you don't have to factor. The factors are already done for you. You don't have to factor, okay? Faith, when you're done, can you give those notes to Osvaldo? So the first thing you're going to do is look for common factors. Good morning. In the numerator and denominator, thank you. You should have a paper at your table. Look for common factors in the numerator and denominator. That's the first thing you should do. This is for level 2. Again, it's going to be factored for you. You don't have to factor them. The second thing you're going to do is you're going to cancel, and I put cancel in quotes because I don't know what other mathematical term to use. Cancel the common factors. Cancel the common factors. So like I did in that example, I canceled out the x minus 2, right? It became 1. And then 3, you're going to use algebra, i.e. substitution. Am I off screen? Substitution. To find the limit. When you're done copying that down, take out your example sheet. On the front, where it says limit 2 on the right of the table. That's where we're going. Anthony? Yeah. We ready? Okay. So let's look at this example. These are the 2 examples on your paper, right? So let's look at the first one. We need to cancel out the common factors. What is the Look for the common factors. What are the common factors in the numerator and denominator? Not 3. X plus 3. X plus 3. We know these are factors because of the parentheses. Even if they don't have the parentheses, they are factors. Okay? So, second thing I need to do is cancel out the common factor. So I'm going to cancel that out. Ivan. And that leaves me with the limit as x approaches negative 3 of x minus 6. Now look, this looks a lot easier than this did. What then can I do to this negative 3 to find the limit? Plug it in. So we have, oops, I can't find it right. So when I substitute in negative 3, it's going to be negative 3 minus 6. Negative 3 minus 6 is negative 9. So the limit is negative 9. Questions? Questions? Are we sure? Are we sure we're sure? Okay. All right, let's look at the next one. What are the common factors in number 2? X minus 4. What do I do with them then? Cross them out. Any questions so far? So we have the limit as x approaches 4 of 2 times x plus 8 over x plus 7. What should I do now? Can I cancel out? Can I cross out any more factors? No. So then what should I do? Plug it in. So it's going to be 2 times 4 plus 8 over 2 plus 7. What did you say? Oh, I know. Mr. Brown. So we have 24 over 9. 24 over 9 will give me 8 over 3. Somebody put that on the calculator and make sure I did that right. I did that in my head. Make sure I did that right.
Yeah, it's 8 over 3.
8 over 3?
Yeah.
Okay. Questions? Are we sure? We're sure, we're sure, we're sure. Okay. On the back of your paper, you have 4 problems. I'm going to give you 5 minutes. We're going to go over the answers, and then you have a 2-question exit ticket. Yeah. I don't know who has them. Do you have the notes? Okay. He has the notes. If you cancel out the numerator and there's nothing left there, what is the number in the numerator? If you cancel out something and there's nothing there, what is it? 1. Cancel out and then rewrite it. Remember, there's cancels out and there's nothing left, it's 1. Okay, so you need 1 over. There you go.
1 over.
1. And then substitute in 1. There you go. Okay, name your calculator. You need calculator. Okay, you're using your brain, that's fine.
So, there's nothing on top.
Because 1 over. Over?
Over this?
Over this.
Oh.
There's still a numerator, so if it cancels out, it becomes 1. So you have 1 over x minus 3. Okay?
Now you know.
Yeah, yeah, except now it's like a table where this is undefined. Okay? Right? Do you need this one? No, you shouldn't have an extra paper. I gave. Hey. There's still a numerator. It's just there's 1 over that. Okay? Make sense? Oh, this should have been -1. You just messed up. But no, your process is right. That's correct. Yes. All right. Are we ready? Seniors. What's the first thing I should do? Very good. Because there's nothing in the numerator now, what should that become? 1. So it's going to be 1 over x minus 3. So what should I do then with this -1? Plug it in, substitute it in. That becomes 1 over -1 minus 3, which becomes 1 over -4, which is -1 over 4. Sorry, I did that in my head. I know your calculator probably gave it to you as -1 over 4, right? Questions? Am I going too fast? Are you sure? Ivan, Osvaldo. Number 2, what should I do? Cross off what? X minus 3, ladies and gentlemen. Now what should I do? Substitute in 3 for x. So we have 3 plus 4, and that gives us 7. Oops, I'm off screen, my bad. Questions? What's the next one? What do I cross out? X minus 4. And I saw some of you doing this correctly, but then changing the 2 to 1. Only change it to 1 if there's nothing there. Okay? So that gives me 2 over 9 times x plus 7. Yep, 2 over 99. Questions? What's the next one? What do I do? 2 over 5?
Yeah.
Hold on.
Because it's supposed to be like negative 7.
Yeah.
Negative 80, 180.
Yep, it should be 2 over 5. I think, if I did my math right in my head. Maybe, maybe not. Wait,
Wait for number one.
number 1.
Is negative 1 over 4?
Yes.
I thought it was 1. Because isn't the negative 1? Isn't that negative 1?
Yeah, it's negative 1, so it'll be negative 1 minus 3. Negative 1 minus 3 is negative 4.
And then the one on the top of the 1?
No, that was positive. All right, any remaining questions? Are you sure? All right, exit tickets come around. It's literally 2 questions. Yeah, see? Oh, 2 questions, literally. Literally, you guys are freaking out. Turn around, sir. I think that's 4.